Good morning. This is Dr. David A. Padgett. This is Weather and Climate, Geography 3500. Today is April 13th, 2021. Let me start to share my screen here so we can get started. So we are getting close to the end here. We're at we are at week uh, week 12. So we only have this week, uh, next week, and then finals week. Uh, so let's get into this week's schedule. Um, so for today, I'm going to uh, do the lecture on tropical storms and hurricanes. I didn't get to do that last week, uh, but I did record the uh, lecture on flooding. That is now up. That was the April the 6th lecture, but I did not get to do the lecture for April the 8th, so I will do that one today. And then on Thursday is going to be a little interesting. Uh, we have the opportunity to participate in a really, I think will be a great symposium, which is the Spelman College Earth and Environmental Health Program uh, for, and it's going to be a virtual climate change symposium. So this week our theme is climate change, uh, and so we will begin. Today I'm going to do tropical storms and hurricanes, and then and then there is an accompanying video on uh, by Dr. Warren Washington, who is one of the world's foremost climate scientists, and you can read his bio here. And then there's a video on modeling historical and future climate change there. And then there's a PowerPoint presentation I might get into uh, today, possibly Thursday. We'll see, on anthropogenic climate change, which is human caused climate change. Uh, Here is just a advertisement for the Spelman College Environmental and Health Sciences program. And so now just make note, even though it says here, uh, so what we're going to do on Thursday is we're going to start here, and I'm going to do a review of I'm going to look at your term paper second draft. So if you're still working on those, again, remember there's a very lenient late penalty. So it's due today, the second draft, but you won't lose any points until, uh, of course, 11 o'clock tonight. And so just be sure that you do that second draft. Let me go in. I'm going in the student view just so that it should have been in student view in the first place. So your second draft of the hometown climate analysis term paper is due, and the instructions are there. So assuming that you complete your second draft, you're pretty much almost done with term paper except for your results and conclusion. And then, of course, you must also create a PowerPoint presentation for your term paper. Okay, so again, for the term paper, again, this is not a group assignment. Apologize for that. So always find something when we switch up. Yeah, this is ordinarily a group assignment, but now that we've gone virtual, obviously that would be extraordinarily difficult to do. So if you see anything that refers to a group paper, that's from last year when we had live meetings, well, at least for half of the semester. Here are the 4 sections of the paper you should have done along with the previous 2 sections. And so you should be well on the way to having your term paper completely done. Again, it's due today at 11 o'clock a.m., but of course you won't start to lose points until 11 o'clock p.m. So do your best to get that term paper draft up to speed at least by Thursday, because at the beginning of the class period on Thursday is when I'm going to kind of look at what you've done, make some comments. Speaking of review, I am absolutely committed to having your midterm exams graded by next Tuesday. So I'm absolutely committed to that. So you will have a very clear picture of where you stand prior to the final exam. I believe that the final exam, I might release it on Friday, April 23rd, and it will be due probably on the 29th. Well, it have to be due on the 29th. That's the last day of the semester. So that will give you as much time as possible to get it done, along with whatever's left to do for your term paper and your term paper presentation. So also beware that, okay, so also make note of the fact that you have article review 8 due this evening, and then article review 9 is due on next Tuesday. So just please be aware of that. Okay, so let's get into today. I think that pretty much sets us up for this week. Just one thing. So please register in advance for the meeting, for the Spelman College Symposium. The Spelman Symposium starts at 10 o'clock and ends at noon. If for whatever reason you can't make it, that's fine. Hopefully there will be a recording that I'll make available later, but it would be really great if we could participate as a class. I think you might find that a little bit more interesting than our weekly lectures. There's a really good lineup of speakers. So there's really a excellent lineup of speakers at 10 o'clock. There will be a keynote by Dr. Marshall Shepard, who was at one time the president of the American Meteorological Society. And then from 11 a.m. to noon Central, there will be a panel discussion with, among other people, Dr. Nataki Osborne, who is a very well-known environmental justice activist and scholar. Your assignment for this week is impacts of climate change upon the U.S. And so you'll go as to the usual place, and the assignment so for this week, the assignment is assignment 11. It is very similar to the assignment you completed last week. It's part of the current studies curriculum, current climate studies curriculum. And so you'll just download the answer form. And so here's the answer form. And again, what you'll do, my advice is for you to delete the answers that are wrong and keep the one that you think is correct. That will be my advice, instead of trying to highlight or circle or whatever. And so you have the so again, you'll do the reading. As you do the reading, you'll come to the question, referring to the reading, and then you'll just answer the question on the answer form. And then you'll move on to the next question. And more reading. I believe I've also included in here a PowerPoint on also included here PowerPoint on how global climate change is measured and monitored. And so this should help you with the answers to some of the questions related to how we measure climate change. So that is this week's assignment. I don't think it's very involved. I think it is somewhat of a less involved assignment than we've had previously. And then on next week, I'm pretty sure we're going to focus upon El Nino and La Nina, and perhaps some issues associated with climate justice, although you should get a pretty good dose of climate justice and as it relates to this week's symposium. In any case, anything that we cover in here will obviously be seen on the final exam. So just be aware of that. So I'm going to go back to the week week 10 schedule and get into this discussion of tropical storms and hurricanes. So before I launch into the lecture, I just want to point out the fact, if you all were aware, that last year, 2020, I mean, a lot of things happened in 2020. But 2020 was one of the most extreme years. Well, not extreme, but it was the most extreme year in terms of hurricanes. Named storms set a record. I think there were here are all of the tropical named storms that made landfall in the U.S. North America last year. So you see this, I think that set a record. So some of the storms had more than one landfall, as you can see. And so again, last year was again 12 landfalls in the U.S. which was a record, and you can see the damage that was done. Interestingly enough, well, yeah, 2005 still stands out as the most destructive year in terms of damage, which is a surprise to me. So, but if you notice, the categories of the storms, fortunately, were not all highs. So we did have the Laura category 4, and then this area in St. Charles, Louisiana, got hit twice, as you can see, within a 2-month period. Laura the first time on August 22nd, and then Delta on October the 9th. But then the rest were either tropical storms or category 1 strength. So the saving grace in all of this from last year was that even though there were a lot of landfalls, most of them were tropical storms. And so, which does not mean that's a great thing. I mean, tropical storms come with a lot of flooding and damage themselves. But at the end of the day, we didn't have a bunch of category 4 and 5 storms. So like Hurricane Andrew was. So given that, we are coming off of one of the most productive years or record-setting years, and you have some other links to look at that, gives us cause to prepare for this year. And we really don't know what is going to happen from year to year. We, meaning, climate scientists, predictions are made, and then sometimes the predictions are correct and sometimes the predictions are wrong. I can't really remember personally what was predicted for 2020 last year, but I guess, as they say, we will see for this year in terms of the predictions. So how do these storms begin? Well, usually the storms for us, tropical storms for us, originate somewhere in the Atlantic Ocean off the coast of Africa, usually as a tropical depression, which is just a low pressure system. And then eventually they move toward the west, pushed along by the trade winds. And if they are strong enough, they will reach landfall and increase to hurricane strength. And so here are the characteristics of tropical storms and hurricanes. The most damaging and deadly part of a hurricane is the storm surge, not the wind, which I'll talk about later when we start to get into how these hazards are measured. But the water, the storm surge, is what causes the most damage. Is where most people lose their lives, is with the flooding and the rain. Notice that the hurricane hazards listed here first are storm surge, rain, and flooding. And then winds are lower down the line. Just keep making note of that. So hurricane strength is measured on the Saffir-Simpson hurricane intensity scale. And so here it is. Now you'll notice that the primary determining factor over what is and what is not a hurricane is based upon wind speed. And so once the wind speed reaches 74 miles per hour and above, then that is called a hurricane. Prior to that, it's a tropical storm. I think a tropical storm is 39 miles per hour to 73 miles per hour. The tropical storm. And then once the wind speeds average above that, from 74 to 95 miles per hour, that's a category 1 storm. And so we had a lot of those. Then next, when we get to category 2 storm, which is 96 to 110 miles per hour, and then category 3, 4, and 5, as you see, topping out at greater than 155 mile per hour winds with catastrophic damage and a storm surge of over 18 feet above sea level. So in most cases, the damage and deaths are caused most by flooding. Notice that, yes, storm surge is mentioned here, but there is nothing in the Saffir-Simpson hurricane scale that refers to precipitation. And so if we look at a storm, for instance, we go back and look at a storm like Hurricane Harvey. So Hurricane Harvey, if you take a look at this, I know it's a lot to read, but I can just give you Hurricane Harvey. Yes, started out, it was a category 4 hurricane, but most of the damage occurred in the aftermath when it just kind of stalled as a tropical storm and dropped 60 inches of precipitation over parts of Houston and the general area. 68 people were killed. And so if you read through this, you'll notice that that the storm created the most of its damage when it dropped all that rain, all that precipitation. Unprecedented amounts of precipitation occurred with this storm. And so here we have where it started out, tropical depression, wind speeds in miles per hour. Well, they have knots. And then, of course, it was a tropical depression at first at August 16th. And then still a tropical depression. I think this is before landfall. And then it became a hurricane and then dissipated down to a tropical storm. They're going way out with this before it even got to Houston. But in any case, most of the damage that came from the storm occurred with the rainfall, not the wind. And so here's the track of the storm. And so it did make landfall as a major hurricane, I believe category 4, but which was south of Houston actually. And so all this yellow area when it was a tropical storm is when the bulk of the damage happened. And you can see here, there's a storm surge. And so here are the precipitation amounts. And you can see that so the landfall was here, but notice that most of the precipitation occurred in and around the Houston area where we got 40 up to 60 inches of precipitation from this storm. So that's what really caused the damage. So here it was a hurricane to the south of Houston, but when it became a tropical storm is when most of the problems occurred. So I emphasize this point in saying that yes, a category 4 hurricane or category 3 hurricane or category 5 hurricane is bad, but we can't relax if we notice that a tropical storm is coming, where it can just dump massive amounts of rain and cause all kinds of flooding. Let's see. So going back to the PowerPoint, again, notice that rainfall or precipitation is not included in the Saffir-Simpson scale. That's just something to point out. And so one of the driving forces for these storms is very warm water. And so with global warming affecting us now, the question is, well, how is global warming affecting hurricane production? So one might look at last year and assume, well, yeah, global warming is resulting in more hurricanes. Last year was somewhat of an anomaly, and I'm not going to speculate. We'll get into the impact of El Nino and La Nina upon hurricanes next week. But I will say that because El Nino results in a weakening of the trade winds. The trade winds are what push hurricanes and tropical storms westward. If those winds are weakened, or when those winds are weakened by El Nino, we tend to have less hurricanes. However, when La Nina occurs, which is when we have a reversal and perhaps a strengthening of the trade winds during La Nina years, we would expect to see more hurricanes. So hurricanes do not happen only in the U.S. or tropical storms rather do not happen only in the U.S. They occur all over the world. However, depending upon where they form, there are different names. So in the Western Hemisphere where we are, these storms are called hurricanes, as you can see. If the same type of storm forms in the Eastern Hemisphere and south of the equator, they're called tropical cyclones. Or if they form in the Arabian Sea or Indian Ocean, north or south of the equator, they're called cyclones. If they form in the Eastern Hemisphere north of the equator, they're called typhoons. So they're all the exact same storm physically. And so we go into the readings for this, for week 10 again. And so I've pointed out some major storms. So here is Typhoon Hainan, that was 2013. I think this typhoon at the time had the highest wind speed ever recorded for a tropical storm. So it was a Category 5 typhoon. At least 6,000 people were killed. And it was one of the worst storms ever. Yeah, the 196-mile-per-hour winds recorded in Typhoon Haiyan. And so because of where it formed, it was called a typhoon. If it had formed where we are, it would be called a hurricane. And so we have then we have cyclones. Here's 2019 cyclone that struck Mozambique. And so one thing that we have to be aware of is that, okay, certainly when we are struck, we, meaning the United States, is impacted by these storms, it is a catastrophic event for us. However, because of our nation's wealth and the fact that that we have resources, we're able to recover from these storms relatively, I don't want to say quickly, but you can only imagine that in places in the world that have much less wealth, when these types of storms strike, say, the Philippines, or in this case, strike Mozambique, the recovery takes a lot longer. And the forewarning is also, people may not be aware. The reach of media and news and electronic media just is not as prominent in other parts of the world as it is here. And so a lot of times when these types of storms strike other parts of the world, doesn't make the news cycle here. It kind of happens in a vacuum. Another thing that happens in other parts of the world in terms of recovery is that these regions sometimes already lack in infrastructure in terms of housing, shelter, sanitation, water. Even here, not that it was related to a tropical storm, but if we look at what happened in Jackson, Mississippi, with this latest ice storm, there were people without clean drinking water in Jackson, Mississippi for a month, and that was here. So that was a place where people already had access to clean drinking water, and that infrastructure got knocked out for a month. So imagine places where there is no infrastructure for clean drinking water or sanitation, and all of that material gets mixed together. And so what happens in the aftermath is you have, as you can see, disease that visits populations. So it's like a double disaster. We experienced that here somewhat when we had all the hurricanes, and then, of course, COVID-19, the pandemic, was happening at the same time. And so a lot of questions came about as to, well, how do we shelter in place or provide shelter for people who've lost their homes or who were flooded out by the hurricane, and at the same time social distance and keep people safe during the pandemic? Those are some very serious questions that were raised during the pandemic, during the hurricane season last week. So these storms, when they do occur in other parts of the world, can be quite problematic. And so here's just some data with regard to hurricane frequency, and this chart probably doesn't go past 2006. But in terms of the relationship between hurricanes and global warming, it's not expected for us to have more hurricanes and tropical storms. What we've noticed is that they have gotten bigger and more powerful. And so fueled by warming ocean waters, we've seen several storms, such as Hurricane Wilma from 2005. So let's see, Hurricane Wilma, I believe, went from a Category 1 to a Category 5 faster than any storm. Yeah, it went from a tropical storm to a Category 5 in one day. Under ordinary circumstances, the storms historically increase one category per day. So maybe on Sunday it's a tropical storm, on Monday it's a hurricane Category 1, on Tuesday it's a Category 2, and so on and so forth. However, Wilma went from a tropical storm to a Category 5 hurricane within 24 hours. And I believe subsequent storms had similar patterns, literally almost exploding, going from a relatively, modest tropical storm, and then the next thing, boom, it's a Category 4 or 5 hurricane. That's something that had never really been seen before, historically. We also, I think, posted a link to a few other hurricanes. I think Hurricane Florence is an example of a hurricane that struck the Carolinas in 2018, made landfall. It was a Category 4 for a while, but when it made landfall, it was only a Category 1. But again, if we look at the rainfall totals throughout North Carolina, incredible rainfall totals: 35 inches, 29 inches, 34 inches of precipitation, even though the storm was a Category 1. So just looking back at some of these storms historically and their behavior is quite interesting. But what the main point is that we have to be aware and alert, no matter what the magnitude of these storms happens to be. Another, going back to the PowerPoint, one thing that I forgot to mention is, and I kind of, is also not included in the Saffir-Simpson scale, is how fast these storms are moving. So even if a storm is a Category 3, but it just goes quickly through an area, yes, the wind damage might be bad. Certainly there might be some other damage from storm surge. However, if a Category 1 or 2 storm like Hurricane Harvey or Tropical Storm Allison or Hurricane Florence just kind of hangs around, doesn't move very quickly, but hangs around, even if it's a low category storm, it keeps hanging around and dumping precipitation, and that can be very dangerous. Because what happens, or really if we go back to what happened with Hurricane Florence, is once it started to weaken, a lot of people who were in voluntary evacuation zones did not evacuate. Maybe here inland, people here inland thought, well, I don't have to evacuate. I'm not here on the shoreline. I can, and then next thing you know, they got 20 inches of precipitation and 18 inches of precipitation and 30 inches of precipitation far away from the shore, And people in those areas were getting rescued from rooftops, and some of them might not have been rescued. So here's some of the flooding images that occurred with that storm. So a lot of people in the path of Hurricane Florence really did relax a bit when it decreased in strength in terms of wind, but the flooding really caused a lot of damage and a lot of suffering for people who did not evacuate. So so here is the life cycle again of tropical storm. They start off as a low pressure, or tropical disturbance is essentially a low pressure center, usually in our part of the world, over off the coast, off the west coast of Africa near the equator. Once that low spinning counterclockwise, once those counterclockwise winds get up to 23 miles per hour, it's called a tropical depression. When that tropical depression reaches 39 miles per hour, then that's when it gets a name. The names for these storms are picked randomly, and they're alphabetical. So the first storm will be, the first name will be A, then the second storm will start with B, like Bob, the third storm, and so on and so forth. If a storm is particularly damaging, then that name will be taken out of the queue for the rest of the time. So here's we've looked at some actual hurricane paths, and that's it. So hurricane season begins June 1st and goes to November 1st. So we're not going to have any interesting data to look at during the class, but already the projections have been made for the season. Let's see, 2021 hurricane season, hurricane forecast. And so, as you can see right now, the expectation is for the hurricane season to be above average this year. Will that happen? Who knows? The conditions are right, but who knows? The same was done. I can show you back in 2006, which was the year after the record-setting 2005 year. There were all kinds of predictions for 2006 that it was going to be a horrible hurricane season, et cetera, et cetera, et cetera. Didn't happen. It was a very quiet season in 2006, and thankfully so. 2004 was bad too. So 2004 was bad. 2005 was worse. There were all these wild predictions for 2006. Didn't happen. And so even with all of our instrumentation and all of our abilities to predict these storms, we still aren't able to predict to 100% certainty what's going to happen. Okay, so again, let's get back. So the information for this week's lecture just now was mostly under week 10. Like I said, I meant to give that lecture during that week, but it didn't happen. And so for week 12, the theme for this week is climate change. And so again, please join the, please register in advance if you can for this symposium on Thursday. And so we'll start off with the regular class meeting time, and then we'll transition into the Spelman College Symposium for those of you who are able to join. And then there's an assignment 11 that's due next Tuesday. Also, you should make note of this presentation, Anthropogenic Climate Change, which covers chapter 12, which will help you with the assignment for this week, along with the other materials. So I'm going to end class, well, end the recording now for today. Thanks for attending. If you have any questions, let me know.